Okay, so today we're going to talk about the division algorithm for polynomials. So if f of x and d of x are polynomials with d of x not equal to 0, and the degree of d of x is less than or equal to the degree of f of x, then there exists unique polynomials q of x and r of x such that f of x is equal to d of x times q of x plus r of x. And this is the remainder r of x equals 0, or it is a degree less than the degree of d of x. So um, remember, using the basic understanding of the division algorithm, we know this right here is what's known as the dividend. This right here is what's known as the divisor. This right here is what's known as the quotient. Oh, I need to be able to spell quotient correctly. Quotient. And this is what's known as the remainder. Okay? And I'm going to show you through an example how the division algorithm works. And we're going to do this using long division to figure out what our quotient and remainder would be. Okay? And we're going to be given a divisor. So let's look at this division of polynomials here. We're going to be looking at x to the fourth minus x cubed plus 2x squared minus x plus 4. This is going to be our function. This is going to be our f of x. This is going to be our function. And the divisor we're going to choose, so the thing we're going to be dividing this by, so our divisor, right, our divisor polynomial is going to be x squared plus 1. All right? So right off the bat, we know that the remainder is either going to be constant or it's going to have a degree of 1, right? So r of x can either be a polynomial or it can be a constant. We're going to figure that out. So to figure out what the quotient and the remainder are, we're going to use long division. So we're going to look at x squared plus 1. And we're going to look at divided into x to the fourth minus x cubed plus 2x squared minus x plus 4. All right, so we can see that x squared goes into x to the fourth x squared times. So this will be, let's go ahead and put plus x squared here. And we're going to have x to the fourth here. And remember, we subtracted here. So x to the fourth minus x to the fourth is 0. We're going to have this negative x cubed. And then 2x squared minus x squared will be x squared. And then we have that plus 4. Or I mean minus x, right? Okay, so now we're going to look at, we can subtract x, right? Because negative x times x squared is negative x cubed, which is what we need. So we're going to get negative x here. We're going to get negative x cubed here. Right? And then this will be negative x cubed minus negative x cubed. That'll just be 0. We're going to have x squared here. And we're going to have 0 here because negative x minus negative x is 0. So then we're going to do this plus 4. And then we can just add 1. So plus 1. So this will be 1 times 1, which is 1. 1 times x squared is x squared. This will be plus. Subtract that. And that'll give us 4 minus 1 is 3. And of course, x squared minus x squared is that. So now I know my I know my quotients and I know my remainder. So now I know my quotient is going to be x squared minus x plus 1. And my remainder is actually constant. It's a 3. So I'll just put remainder here. Remainder is equal to 3. So now I have that, remember, the division algorithm, f of x is equal to d of x times q of x plus r, right? In this case, it's just going to be r because we know it's a constant. But of course, we can write r of x, right? So, based off of this, we know that our original one, f of x, is equal to x to the fourth minus x cubed, that stuff, right? So, x to the fourth minus x cubed plus 2x squared minus x plus 4 is going to be equal to, so the divisor we chose, remember, was x squared plus 1. So x squared plus 1. And the quotient we got was x squared minus x plus 1. And our remainder was 3. So, apparently, this is equal to this. We can check this really easily, right? So let's look at, so this is equal to this using the division algorithm. Let's see. Let's go ahead and look at the left-hand side here, right? So this is x squared plus 1 times x squared minus x plus 1 plus 3. That's going to be equal to, so x squared times x squared is x to the fourth minus x cubed plus x squared minus x plus 1 plus 3. And this will give us x to the fourth minus x cubed plus 2x squared minus x plus 4, which is exactly what we wanted, right? So we've shown that using the division algorithm that this function here, this polynomial, can equal to divisor times the quotient plus some remainder, right? And this is how the division algorithm works for polynomials.